Greetings and welcome, friends. We're taking a gander, a look, if you will, at last night's quest, page 16, in Big Ideas Common Core Geometria textbook. Here we go. I'm just going to go over 3 questions. Problem 1, writing. Man, here we go. Explain how xy and xy are different. Well, xy with this bar over it is, this might be limited in my writing because I'm just like, interested in time and efficiency here. XY refers to, here we go, to a segment with endpoints at X and Y. Yeah, endpoints. So it's referring to an image at X and Y. Yeah, it's been all summer since I've written, so pardon my writing. Well, xy without that notation over it refers to the length of segment xy. All right. In terms of, we talked about equality and congruence. I would refer to, I would use congruence. For instance, segment xy would be congruent to segment yx. Reflexive property of congruence, we'll talk about that later. Whereas xy is a number. All right, so one of these refers to an image. So this one, for instance, segment xy would refer to the diagram, the sketch, the segment itself, the picture, if you will. Whereas xy here, without the bar over it, is referring to a numerical value regarding its length or distance from those 2 points. Okay, so that's kind of the big idea at play there. For segments or images or shapes or polygons, we would end up, this is beyond the question, the scope of it anyway, but that's fine. We would use our congruent symbol, which was like an equal sign with a squiggly toupee. And when I'm referring to just plain old xy, I would use an equal symbol as a relationship between those things because they're talking about numbers, right? Numerical concepts at play. So that's question 1. Gave you a little more than I needed. Let's see, in questions 9 through 14, plot the points in a coordinate plane, 2-dimensional plane, and then determine whether A, B, and C, D are congruent. Let's see. Oh, let's see. I can open my ruler tool here and be really fancy. I've never used this live on a video, guys. Look at that. Look how great. It's almost like a straight edge. It is. I could actually arguably try to test for perpendicularity here, but I'm not going to be too picky. That's close enough. So here's my coordinate plane. And close that out. Looks like I got to go from -5 to +3. So I'll just throw some tick marks in here, hopefully somewhat equidistant. And for the y-coordinate, 6 is the max, and -1 is the lowest, so I don't have to go too far on the negative y. 1, 2, 3, 4, 5, 6. All right, here we go. Green for point A. -5, 6, so I'd go left 5, 1, 2, 3, 4, 5, starting at this point, which I think we talked about the other day, which is the origin, also known as EA's kind of competitive software market, competing with Steam from, of course, the company Valve. But seriously, go Steam all the way, represent. 1, 2, 3, 4, 5, and then up 6. Oh, it looks like I'm landing right here. Here's my point A. That's fine. Point B is -5, -1, so 1, 2, 3, 4, 5, down 1. So there's point B. And let's use a different color for C and D. -4, 3, so 1, 2, 3, 4, and up 3. Wow, you guys, it's all coming back to you, right? And D was 3, 3, so right 3, up 3, D. There's point D. So now to ask the questions, then determine whether A, B, and C, D are congruent. So these are referring to the segments, but in order to answer that question, distance would be the thing of interest to me. So if I want to find the distance from A to B, we're going to talk about kind of more 2-dimensional distance measurements today. But these conveniently happen to be vertically aligned. So really, to find the distance for AB, AB is just going to equal the absolute value of the difference, not distance, difference of their y coordinates is all I'd have to do. So absolute value of 6 minus a -1, and that looked like an I. So 6 minus -1 is 6 plus 1 is 7. Abs 7 is 7. All right, so that's a number. Notice my use of equal signs. Whereas CD are horizontally oriented points, and I would therefore look at their x coordinates, and the length of CD is going to be the absolute value of their difference. And I could do this in any order. Let's do -4 minus 3. -4 minus 3 is becoming more negative, so that's abs val -7. Man, my writing's got to improve here, friends. Man, it's like the high definition is just making it uglier. If I should have just done this at like 480p. -7 absolute value is going to be +7 because, here's the logic, because their measurements are equal, therefore the segments are congruent. All right, so therefore segment AB is congruent to segment CD. And I could even say, since AB, the number, is equal to CD. All right, that's the congruence definition of congruence postulate. Def of Kong will be, man, you and Def of Kong, you guys are going to be best friends this year. It'll be great. So that's that problem. Last question, question 28. Write an expression for the length of the segment. So here we go. We've got a sketch. We've got A to B, B to C. B appears to be on segment AC. So if I want to represent AC's length, notice I drop the segment symbol when I'm talking about the number. And segment AC is going to equal AB plus BC. The sum of the non-overlapping parts is equal to the entire length. It's kind of segment addition postulate, right? The big guy is equal to the sum of the little guys. AC is therefore equal to, might as well do a recall here, right? Substitution property. If this is truly equal to AB, then I can substitute in right here. And if this is truly equal to BC, we'll swap colors one more time here, right? Then I can substitute that in for BC. All right. I guess I should be consistent with my sideways bracket thing. So once I just substitute those values, I'll get x plus 2 plus 7x minus 3. And of course, we could simplify this doing what's known as combining like terms. Here I've got 1x plus 7x's is how many x's? 8 x's. It is not 8x squared. There's still x's. Like 1 apple plus 7 apples is 8 apples. It's not suddenly apple pies. It's just apples still, friends. We didn't do anything to those x's. And then let's get a different color here. Bam. Adding the like terms of +2 and -3. Those combine to be -1. So that would be an expression that represents the length of AC. Did the book end up simplifying that? I don't recall. They probably did. They probably simplified it to 8x minus 1, right? Okay, I'm getting some nods here. Internet, give me some likes. Yeah, okay, you guys post it in the comments below, perhaps. All right, B, part B. Here, this one's more interesting. QR. Well, QR is not the big length. So let's actually rewrite this using segment addition postulate. So PR would equal PQ plus QR. All right. So now I'm going to plug in. Let's see. So here is PQ. So I'll plug that in right there. And here is this length is the entire segment. That's PR, so I'll plug that in right here, right? And I do not yet know QR. Now, theoretically, I could do some, I could do some subtraction, like before I do the substitution, or I could substitute and then solve for QR. It doesn't matter either way. Let's do the solving for QR post substitution. So let's see, I'll have 13y plus 25 is equal to, yeah, get that, yep, 8y plus 5 plus QR, which just represents a number. It's just a number, so don't be scared. So let's see, if I want to solve this for QR, I can subtract. I got to get everybody away from QR. Like these guys got to get quarantined away from QR here. Let's see, minus 8y from both sides. I subtracted from both sides because, of course, the subtraction property of equality, in order to maintain equality, that looks almost like a tri-quality there, but just pretend it's an equal sign. So I subtract them from both sides in order to maintain equality. 13y's minus 8y's is 5y. And yeah, now it's just classic algebra. You guys are experts. You're in geometria here, right? And then I could subtract 5 from both sides. And notice I line these up under their corresponding like terms. Might as well. Keeps things organized. And tell you what, I'm going to reflexive property this all at the end here. So QR is going to equal 5y plus 20, if I'm not mistaken. All right, so there we go. Well, thanks for watching, Internet friends. Hopefully you enjoyed. Bye-bye.